This is number 5 in packet number 19. We have a line passing through the origin is tangent to the curve y equals e to the x when x is b. We want to find b and the equation of the line. Well, let's draw in that line. So if it goes through the point b, e to the b, as I've already put in, and it goes through the origin, then I'm going to have a line that looks like that. Okay. Now, the slope of the tangent line equals the slope of the curve at the point of tangency. So, if we have the curve, if we have the equation y equals e to the x, e to the x is a fantastic equation. It is the only equation whose derivative is the same as the original function. So the derivative of e to the x is e to the x. Now, so that's the curve. That's the slope of the curve. For the slope of the line, well, we need delta y over delta x. And because we're going through 0, 0, and b, e to the b, that's just going to be e to the b divided by b. The slope of the curve and the slope of the line have to be the same at the point of tangency. So we can equate these two together at the point of tangency. So the derivative at x equals b on the curve is e to the b. So e to the b, putting those two together, e to the b has to equal e to the b over b, which by inspection, just looking at the problem, or you could do more calculation, b has to be 1. So we've taken care of the first part of the equation. We found what x is, what b is, the value of b. Now we want to know the equation of the line. So the equation that I always use is the point slope equation. I have my point, which since it was b e to the b, and I know that b is 1 now, I have 1 e. So I have y minus e equals my slope times x minus 1. Well, my slope is e to the b, and b is 1, so it is just e. If I do a little computation and I recognize that my line goes through the origin, either way I can find out that the simplified version of the line is ex.